Hello, hello. Am I audible? All right, beginning of a fairly interesting episode this week. Um, Not the entire set I really wanted to talk about, but yeah, I have tried a few things and they seem to work really well. We are talking, in fact, about trying to run the Ultra96 on the newly released Vitis platform and how you can do it much more easily rather than creating your own blog design and going through the whole Vivado process as well. What is the quickest route to get a design up and running? And that is sort of what I wanted to talk about today. Now, before we get started, couple of announcements. I think we are going to have a bit less amount of people in the call today. Something went weird with the invite, so I have resent everyone invite, and not everyone has seen it yet. Although I made it a point to also inform as many people as I can personally on various chats and stuff. So yeah, a bit light on the attendance today, but I think that's going to be fine. Um, yeah. So again, couple of news related announcements that I really wanted to talk about before we get into the Avnet Ultra 96 and Vitis stuff. Is that there are two very good announcements from the ARM ecosystem perspective. The first one being that uh, Cavium, they were bought by Marvell, so technically Marvell and Microsoft have ended up in a deal, and Microsoft will now host Thunder X2 platform. So they are very high core count, server grade, um, basically rack mount servers by Marvell, ARM V8 64-bit, all of that good stuff. Really well regarded in the community. So they'll be hosting that over Microsoft Azure initially for testing only and like internal work, but hopefully that goes into public access as well, which would be a very nice thing to have. Hate it or like Microsoft, I don't care. Be a person not a big fan, but they are pushing ARM 64 and ARM CPUs in a big way, both in consumer and server market. So that's actually pretty good. Um, Moreover, the other news was Fujitsu. They have their A64FX platform, which is a high performance compute grade, so a supercomputer grade platform. It's uh, like 256 threads and stuff like that, really high core clock count, and designed for that kind of workload. They and Gray have actually got into a deal to get that working and have a proper supercomputer built using these processors. Um, so yeah, ARM in supercomputer, ARM in server land, and that's where we see everything go. Hopefully, we have a desktop system soon enough, but that's been a long wait. So yeah, that's kind of that for now. All right, moving on to the topic at hand, Vitis on R26. I'll literally walk you through every single step in this episode. We have an hour, should take a bit less. It's actually Vitis is much simplified to work on, especially when you see it happen and you compare it with the things you had before from Xilinx. So what is Vitis? So Xilinx took their whole suite, which has SDX, HLS, Vivado, Peter Linux, Execute, blah blah blah, and just sort of unified everything inside this thing called Vitis. Uh, so now there are only three components to it. There's Vitis itself, there's Vivado, which is now a part of the Vitis package, and then there is Peta Linux for handling the Linux operating system kind of side of things. So now you just have these three things to deal with. Vitis does all the uh, C to HLS conversion, and yes, the OpenHours now. There are people messaging me and asking me if OpenHours is now. Yes, it is. Um, and oops, I'm just moving people to panelists. Yeah, so a new platform to take a look at and to understand, but one that is very much integrated and that will actually help and simplify a lot of things. So I just wanted to show you the Vitis the main actual page for that. So I'm just going to share screen there, and hopefully you all can see that set screen. Yeah, so this is the Vitis homepage. They have sort of you know distributed into a few over like few libraries and few subsets, AI, machine learning, and all of that stuff. And uh, within each of these various software platform, accelerated libraries, and embedded software and ecosystem um, lies like a bunch of other libraries. So yeah, so these are the nine major markets or use cases they are trying to target. You have AI, automotive communication, database, financial technology, which is a big thing because in stock markets you really want a very high performance, and people do use FPGAs there a lot. FPGAs and ASICs outperform your regular CPU in that area. High performance computing, industry, IoT, network acceleration, video image processing, and each of these has like a bunch of libraries built in. They have samples for everything, so you can just select what board you want, apply that, and they have like a sample for you ready with all of the training material and stuff you want to follow and get Vitis running. So that's what Xilinx is handling on their end. What I wanted to show you guys today is how to get started with the first basic project. We are going to tackle the standalone variant now without FreeRTOS on Linux. I was working on getting Linux working, but that's a bit more complicated. I think I missed a few marks here or there, and that way I couldn't really get it working for today. But maybe next week we'll try that out and I'll show you a few proper demos. But today we are just doing the Hello World stuff. So the first way to do it is to open Vivado and like write your own hardware definition, create your own block diagrams if you know that stuff. If you don't know that stuff, there is a much simpler way that you can follow. So all you need to do is get into this particular URL. So at this AppNet's GitHub page, and they have a Ultra96 dash pink repository. From there, move on to the Ultra96 folder. You can see the sensor v1 and v2.bsp. This is what you need. Now this BSP is for Peta Linux, but you really do not require Peta Linux for standalone. You require Peta Linux only for the Linux based applications that you um, might want to build. And so you go ahead, you download just the BSP because we need the files that are in the BSP, and we are not looking into making the actual stuff, the actual Linux part. We just need the hardware files from there. So I'll just go and copy link location and just go into my terminal, which will be on your screens in a bit. Let's see. Uh, so I am on my in my Vitis folder. I can just do wget. Actually, not the correct URL like that. So the correct way to do it would be open that up, select that download thing, copy. link address, link location. Go here, run a wget, paste the link, and wait for it to download. Now, there are times in this demonstration where I have a bit of free time, so feel free to ask questions. Like, it's not like I don't really have to say anything for the next 13 seconds. So feel free to ping me, feel free to ask questions on all channels. And yeah. All right, so we are done with it. Now, how do you extract that is you rename it. I'll actually make a copy. But you rename it to sensors.tar.gz. So that's the actual compression. But for some reason, we'll just rename it to BSP. And then you extract that. So you go tar xzbf and sensors.bsp, sensors.tar.gz. It will extract in a second and into a folder called sensors 96B. So you go in there and you do ls, you can see all the files are there. So now what you want to do is to start Vivado, and what you want to generate a XCS file. So we are not going to go too deep into Vivado. You just need to generate a file from the files that are already in there. That's why you need to start Vivado. So first of all, source Vivado from your installation location. uh, Oops, supposed to be there. Oh yeah, source. Oh, there, and settings 64.sh. Once that's done, you can call on Vivado simply by running Vivado, and it should start. It takes a while. So
So while you're waiting for that to start up, the .bsp extension on the sensors is in the PETA Linux environment. It automatically recognizes that
yeah,
as a tar.gz file. So that's why it's named that.
yeah. I think that's the case. It's just it needs to see that .bsp to for it to properly take a look. So yeah. So once we are into Vivado, all we need to do is open project and go into your sensors 96B hardware, this one, and the .xpr file. Uh, and now you want to open it in read only mode because that one was built for a older variant of Vivado, which is 2019.1, and everything that's under Vitis. So when you install Vitis, everything that's under Vitis is for 2019.2. But you can always open it in read-only mode, and it will be happy with that. And that's all we have to do now. Otherwise, you can also go in and go through the whole entire automated conversion process that will change it to 2019.2. Hopefully, without breaking much things. But for this purpose, we are actually just sticking to 2019.1. So once that is on, you don't need to do anything. That particular BSP package already had all the bit stream and everything written to it. You just need to export it. So you go File, um, you go export hardware. You can see XSA file name. This is what we want, and export this to a place where you can recognize it. So I'm just going to export it to my Vitis folder. So it will be sensors 96B wrapper. I'll just add a V2 in front so I don't get confused. And we said okay. And this will only take a few seconds though. Or it's taking a bit more than a few seconds, but yeah, should be done in a bit. Um, but in that time I can actually show you guys my setup, and we'll get back once the export is done. So stop share and go to this camera, and on my workbench, I have the Ultra96. This is the V2 board, and this is the JTAG pod. So this can come out. This is what's used to deploy all the FPGA designs on the Ultra96 live from the debugger directly. Otherwise, you would need to add like make a SD card image and go from that route, which is kind of a bit disappointing and long thing to do, and also you can't debug it. So you can just remove this pod uh, like that. So it's just a simple PCB, and you can just attach it. There are pins on top and the bottom, like so. And that's kind of your platform that we'll be testing on. So we'll just move it back. Give me a second. There I am. Share my desktop. It's great. Right. So we are back, and um the files were created. Sorry, I'm just promoting people to panelist in between. So the file that we wanted to share out, the file, XSA file, has been done. So you can minimize that. And if you do an ls here, you can see we have our XSA file here. And now all we need to do is open Vitis. And that's it starting up.
So Vitis ID replaces SDX.
Yes, SDX, HLX, whatever there was different. Also, not like it doesn't only replace that, it also incorporates all of the OpenCV, XF stuff and other FPGA specific libraries that Xilinx had scattered around all over GitHub. You can just go in here and we'll take a look and just import them directly without having to manually copy files from here and there and stuff like that. So it's very much integrated environment now. Right. So once this opens up, you create a new platform project. This will create your hardware platform. I'll just call it. Um, we'll call it UV2 OpenHours so that I don't get confused with a bunch of other test platforms I have created over the time. And hi to A13 as well, who says hi on the chat. All right, so we are here. We have created the platform. We go next. We say create hardware specific XSA. That is what we want. And we'll browse our XSA file from here, the one that we just created. It again takes a few seconds to read all the stuff from there, and it will give us options to choose, and then we can start working on it. There we go. So we have the option of selecting our A53 cores, our Cortex R5 cores, the real-time ones, and the PMU. Um, if you add a microblaze design, it will actually have the option for microblaze as well. So it supports all of the platforms that Xilinx currently supports. So we are just going to go with the standard Cortex A53, although Cortex R5s would work just the same. You have the option of FreeRTOS, Linux and standalone. Both FreeRTOS and Linux require some files to be present from the BSP. And Linux requires Pita Linux pre-built. So we'll take a look in some other time because Pita Linux takes a lot of time to work on. So once we are done with this, you can just click on finish and wait for it to generate our IDE. Any questions so far? This is going to take time.
I'm late, and I'm going to fully admit that. But did you go over what the differences are between the Ultra 96 V1 and V2?
No, no. I'll do it later because kind of the scope was just to get Vitis working on V2.
Not a problem.
But yeah, I mean there are some basic changes from the Wi-Fi chips that they use. So it's a bit more FCC approved and stuff like that. More industrial grade, higher temperature range. Yeah, minor changes, but changes enough to make it a completely different platform. So A13 asks, uh, since he joined later, what are we doing exactly? So let's actually get over that again. I'm This is a kind of a walkthrough to have Vitis IDE, which is Xilinx's new all-integrated development environment, running on the Ultra 96. This is the basic steps to get it up and running. Xilinx actually has multiple examples that you can follow, but you would need these basic steps to actually get the environment setup and a device setup. So that's kind of what we're going through. Um, we already went through getting the XSA file from Vivado generated using the BSP. And now we are at the point where we are setting up our platform project so that we can import it into our application project. So we imported the XSA file, and now we are just going to modify a few bits that is require modification and move on from there. So the first thing we need to do is we have three projects here: Zinc MP FSBL standalone on Cortex A53 and PSU FSBL. So on all of the three BSPs, we need to modify a bit that tells you which UART is to be used, where Vitis defaults to UART 0, whereas we are using UART 1. So we need to go ahead and modify the BSP settings. And here in standalone, it's actually easy. We can just select UART 1 from here, like so. Well, there you go. Okay, and it takes a second. There we go. But on the other ones, for some reason it doesn't really show up. So we are going to use another technique there. So here, as you can see, it doesn't show up the UART ID. So we are actually just going to close that, and we are going to open this up in Explorer view. So we need to zinc mpfsbl. We'll go here, and in there is the PSP folder and the system.mss folder, and in there you can see in the first few lines there is the UART 0 mentioned. Just going to move it to UART 1 and save, and same for the zinc mp pmu firmware, and the same file system.mss. Again, UART 0, move that to UART 1 and save. Um, right, so that's done, and then we just go ahead and build this. Uh, Select this and select build, and it will take a few moments to build. Um, I still think this is like a single threaded process, so it might take a bit. Again, feel free to ask questions while we are waiting for the build to finish.
Is this new IDE only GUI, or does it have command line tools as well?
So the always like with Vivado, you have entire command line tools. With that is what a lot of the open source ISA stuff uses. Is if you want to run it on Xilinx, they just have a script that runs through the Vivado commands. But for the most part, this particular ID is GUI focused. Although you do have a XSCT console here that you can use for basic stuff.
Good to know. Thanks.
So is it looks like it, is it still Eclipse based?
Yeah, it is. Yeah.
Okay. Is it a newer version of Eclipse?
Not sure. Let's see if it says something about that. Says copyright Eclipse 2000 to 2019. Doesn't say the specific version. Um, 2.2. Sorry, 3.13, 4.8, and 4. So I don't know my Eclipse versions, so I don't know if that's new or old. But
Yeah, and
it seems
I
to
don't
be pretty
remember.
new. Yeah,
I don't
it's
remember what SDX was based on either. So
yeah. So it actually says 2018, so I'll go by select the 2018 version. Um, yeah. Right, the build is finished. That is nice. Now we move on to actually making the Hello World app. So with this, um, our base hardware definition kind of is done. Our platform is ready. Now we can make multiple projects using just the same platform. So that's nice. So we are just going to do v2 app OpenHours. Um, and this is our application project. So we select next. Select the platform you just created. Again, this is the lower ones are the older ones I was working with. This is the one we just created. And here you can see this is all already selected from your platform. So you don't have any choice there. You need to modify the platform. You need if you want to modify all of this stuff. Um, from there, we go ahead and uh, wait for it to fetch templates so that we get our Hello World example pre-built for us. And here we are. We select Hello World and we select Finish. So I have hid my video because there are a few things I just saw that you guys might need to see where my videos. So just remove that. Yeah. So as you can see, our app is now up, and we can actually go into the source and see the actual code right here. So it's a basic code, like literally 4 lines. Um, Edit platform, print hello world, and return. And that is all it's doing. There's something else in the platform stuff, but that's all auto generated. And this is what we are dealing with. So all we need to do is modify just one little thing in the debug option. Now, I'm not sure why this is required at this point, uh, but so the single project debug, and here deselect use FSPL, and save. I think that's it. So yeah, I don't know why it's required. Adam Taylor mentioned it in his blog, so I'm just following suit. I will look into it why it's actually required and give you guys enough explanation. Hopefully, sometime next week. But yeah, we are more or less ready to deploy. I am just yeah. I'll just move over to the. I'll start the video. No, I'll have to stop the screen share for this and move over to the actual Ultra 96 there so that I can show you guys how it starts. Um, so just add the debug head pod that powers up, and then the power cable is already connected. I just need to switch it on. And as with all my Ultra 96s, it's on, the power is on, but I still need to power the board on itself from this button. And now the board is on, so we can go back to streaming, sharing. All right, so yeah, let's go ahead and run the example. For the first, we just enable the Vitis terminal so we can see what's happening. You can use any tool. You can use Putty or you can use Picocom, Unicom to do this. They just provide the terminal, so I'm using it. And it's the standard 11 115 200 bit rate. So nothing fancy on the serial terminal side. It's all generic stuff. Um, and here I'll just go ahead and I'll show you guys the debug stuff that happens that you can do. You can actually going to go through step by step, and then just launch on hardware. I don't see I don't understand that one in particularly, but okay. And we wait. There we go. And there is a terminal. So now, in order to get the hello world, since this is debug, we should actually. Oh, what happened there? I honestly do not understand what that error message was. So I can stop and relaunch it. Huh. I So we have the PSU Cortex A530 here. We have the correct board installed, and I tried this just before OpenHours, and that seemed to work just fine. Let's see if we rebuild it. So it builds
You
for
failed to
A53.
make the proper sacrifices to the demo gods.
Yes, I did. I absolutely did that. Um, let's see. Debug configuration here. Use FMB for initialization. Apply. Same here. I think this should hmm, work now. Right. Debug. Launch on hardware. No errors so far. Yep, that should work. Virtual terminal is up. Yep, there we are. We have our A53 running, and then we can actually. There we go. The application has launched. We are in the init part, and we have our step button here available. And now we can click it. It goes, and on the virtual console, we should see "Hello World" typed out. So yeah, so you can actually follow your code step by step as with any UI or non-UI based debugger. You can suspend it midway if there is a loop, and you actually get to see all the memory location and whatever the current instruction is, which is as you would expect in any debugger to do. So yeah, I guess that's about it. Um,
So A13 asked about where the code's actually running. It's not an ARM core program to the FPGA. The Ultra96 has this
Yeah.
has the SoC that has
yeah,
4 ARM 53 cores as well
yeah,
as 2 R5s, correct?
yeah. So that's the case, and I think what we disabled there uh, made it work because the first stage bootloader doesn't target the A53 cores to launch, and maybe that's why it was not working, and it says the core is not available. Um, so yeah, I mean, it's fairly much like much more integrated. If you see my older video, like we are done in like half an hour. I thought it'll take more, but if you see my video that I made for the SDX platform, it just took a long time to make all of this work because you have to pull libraries and everything um, from places. And I mean, although the ARM cores aren't programmed onto the FPGA, there's nothing stopping you to take the M3 and the M0 core that ARM provides for free and just uh, kind of integrated it um, into the FPGA design, and that is also targetable by the Xilinx platform. The other thing I wanted to show you guys is for a set project, you can actually go here, set libraries. Uh, I have already downloaded the excited libraries folder, um, and if you press OK, it starts to include it. There are examples. So yeah, here are the good stuff. So we have HSL, C++ kernel examples that do that offload a lot of hardware excited stuff. Um, Again, a lot of stuff that was built on this, a lot of OpenCL examples here. So your basic OpenCL apps should work with minor modifications, and a bunch more stuff. You can also add OpenXFCV similarly and use with that. So I'm hoping that I can achieve that sometime next week and show it to all of you. But yeah, this time I was just focused on at least getting this running with the BSP we have. Uh, and yeah, I wasn't aware that the BSP locations were changed for the V2. So I'm going to update the doc as soon as I get the chance. And you guys should see the updated BSP location. Um, yeah, so I don't know if you guys saw the Twitter post I made. I'm not really feeling well today, so I might cut this one short. I'm open to questions now. If anyone wants to ask anything more, and then we might just go into after hours.
Hi Shahaj, this is Soumya.
Hey,
I have a couple of questions
yeah,
since I saw that your IDE support the C++.
yeah,
So, is it modern C++, I mean the CMake files build system that we can build?
yeah. I think I'd hope so. But I think actually, you know what? I don't think it uses make, to be honest. Maybe internally, but you have to go through their, add a file and add a library through the GUI to do it, and it will automatically like generate a make script for you and stuff like that instead of manually doing it. But yeah,
Since
the
it's based on Eclipse, I would bet money that it's using Maven.
hmm, yeah,
Yeah, I would guess if you bring up the IDE again and go into your application, just try to add a C++ source file and see what it does.
yeah. Let's go. New file. All right, so it doesn't just have an option for adding a C++ file. But you can actually go here and say it just adds a file there. Um, I mean, it doesn't expose like any other um, make file in the file structure. Even the .prj doesn't show much. I mean, it's a good question how it does it, but I'm guessing that it's mostly integrated into their IDE stuff, and they really don't want you to see how they do it. Um, like that's my best answer. I'll have to ask around about that.
Okay, thanks. Yeah.
And yeah, um, so I'm closing this out. Again, you have one more chance to ask any questions you have. Okay, then. See you, everyone. This was, sorry about that. This was a very short video, but I hope this episode just serves as alternate T6 V1 V2 getting started with Vitis guide for standalone applications. I will tackle Linux and FreeRTOS based stuff over the coming weeks, since this is kind of what I'm majorly working on these days. And yeah, hope to see you guys next week. If you want to see it running on Linux or FreeRTOS, do join in, and hopefully we can have a longer session. Thank you, everyone, and I will see you all in the next one. Bye, YouTube.
Thanks, Ahash.